Let's discuss about the electrolytic cell. So electrolytic cell is the one in which the electrical energy is converted into chemical energy. So chemical energy is nothing but the several chemical reactions. In order to get the several chemical reactions, we are going to use the one external source, that is called external energy. We are going to apply here. So that is called battery. We are going to connect this cell with the battery. So battery which is containing the positive and negative. So this negative terminal which is going to be connected to the cathode means always reduction takes place, and this positive terminal from the battery which is connected to the anode means oxidation takes place. Oxidation means loss of electrons, cathode means reduction, gain of the electrons. So let's discuss about this electrolytic cell. So this is an electrolytic cell. So this is a tank. So we are going to see this one tank. In this tank, the copper sulfate electrolyte which is going to be contained here, and these are the two rods. These are called two copper rods. One rod is called anode copper rod, one more is called cathode copper rod. When DC is applied, means direct current we are going to apply here battery. When this voltage is applied here, what happens? The several reactions of the cathode and reduction takes place. Cathode reduction, that is, first I should write the cathode reaction. Cathode means always reduction will take place. Reduction is gain of the electrons. So Cu2 plus 2 electrons, that becomes Cu. So at this position, these pure metals, copper metals, which are going to be deposited on the cathode side. Cathode means negative terminal, negative charge. So here, what about in the anode position? In the anode means loss of electrons will take place. Loss of electrons means Cu, that is readily loses the 2 electrons. Right? So at this stage, anode is called impurity, because in the big industries, what happens? In order to purify the copper metals, what they have to do? They are going to take an improper copper metal as an anode part, and proper one, that is a systematic one, pure one copper, they are going to take as a cathode. So when they are applying the DC or battery voltage cell, what happens? The impure metal that can be converted into a pure cathode, that is called, these pure one which is going to be deposited on the cathode side, and impure going to be collected at one side, that is called anode side. So this is about the electrolytic cell. Let's discuss about the electrolysis and their products of the electrolysis. Let's take the definition here. The decomposition of the electrolytes into a similar substances by passing the electric current through a electrolyte, that we are going to call as the electrolysis. It means we are going to see the electrolytic cell, right? What happens? The pure metals which are going to be deposited on the cathode side, right? Impure metals we are going to call as the anode here. So when you are going to passing the electric current through the electrolytic solution, that is called copper sulfate solution. So that process, decomposition of this process we are going to call as the electrolysis. So let's discuss about the products of the electrolysis. So these products of the electrolysis, what we are going to obtain here, that is mainly depends upon the nature of the material what we are going to use here, or what type of the electrodes we are going to use here. So let's take here, if the electrode is inert. So here two comes category, that is electrode is inert and active. Active example, active means copper metal, and inert means that is platinum or gold. These are the example for the inert. Inert means, inert electrodes means they are not participating in the chemical reactions. Only they are act as a part of that electrochemical cell in the reaction. So you have seen in the She, right? Standard hydrogen electrode. There we are going to use the platinum metals, right? So what happens? That act as a source to take a chemical reaction, right? So that's why they are called as the inert electrodes, and active means copper. Just we have seen in the electrolytic cell, right? So when the copper is dipped in the container, what happens? Two types. So now I am going to take this copper, and this is the copper sulfate. So two types of the possible products of the electrolysis, right? So one is called oxidation, another is called reduction. So oxidation means loss of the electrons, and reduction means gain of the electrons. So like this, they are going to involve in the chemical reactions. But what about this platinum or gold? So these are not going to be participate in the chemical reaction. That only they are telling. If the electrode is inert, like platinum or gold, it does not participate in the chemical reaction. Which is not going to be participate in the chemical reaction. It it acts as a only source to make a several reactions. Let's look at the second one. If electrode is reactive, like copper metal, if it is reactive, it is participating in the electrode reaction, that is electrochemical reactions. Thus, the products of the electrolysis will be different. So, we are going to obtain the different one. So, now I am going to take only same electrode, right? So, that's why we are going to obtain the same type of chemical reactions. If I use the several types of one, we are going to obtain the different for different reactive and different electrodes when you are going to use here. So next one, the products of the electrolysis mainly depends upon the different oxidizing and reducing species present in the electrolytic cell and their standard electrode potential. So means here oxidizing will be there and some of the species containing the reducing. Reducing means they are going to take reduction. Oxidizing means loss of electrons. They are going to be takes place in order to get the different products of the electrolysis. Let's take the example for the products of the electrolysis. Now I am going to take an NaCl, right? So NaCl, the molten NaCl, which is going to be electrolyzed. So you are going to get the one is the two products of electrolysis means two types will be there. One is sodium metal and another is called chlorine gas here. So the sodium metal, that is cation, which is going to be reduced at the cathode, and the Cl minus, that is chlorine gas, which is going to be oxidized at the anode. So these are the respective reactions, right? So this is the products of the electrolysis for the NaCl is sodium plus and chlorine gas will be there. But what happens? So this sodium chloride, when it is going to be dissolved in the water, so that is called electrolysis. Sodium chloride, when it is going to dissolve in the water molecules, what happens? So they are going to obtain the products of like this NaOH, hydrogen gas and chlorine gas, which is going to be obtained here when this NaCl, that is salt or electrolyte, when it is going to be dissolved in the water, we are going to obtain like this products should be there. I mean, here we are going to obtain the two types will be there in the cathode side as well as the anode side. What are those? At the cathode, what are the possibilities here will be there? Because when you take the NaCl, I am going to write as like this: Na plus and Cl minus. When this NaCl is dissolved in water, now I am going to write as H plus and OH minus. I mean, the competition between this Na plus and H plus will be there, as well as the competition between Cl minus and OH minus will be there. So that's where the reaction takes place at the cathode. That is called reduction. That is called Na plus. First I should write the Na plus because the two types will be there, Na plus and H plus, because when this NaCl is dissolved in the water molecules, this Na plus which is going to be acquired electron to become a sodium metal, right? So its reduction potential value will be minus 2.71 volt. And also hydrogen will be there. Hydrogen which is also acquires one electron. To follow this reduction potential, it is always 0 volt for the hydrogen. But what happens in the cathode reactions, always we should prefer the more value of the standard reduction potential. So comparing the sodium metal and hydrogen, which one is will be the more reduction potential? It is called 0 volt. This is minus 2.7 volt. That's why I am going to consider this one H plus here for this reaction. So that's why I am going to take an H plus reaction. But how this H plus is going to be produced? It is going to be produced by the water, that is called in the liquid form. So that I am going to write as H plus and OH minus. So now what is the net reaction for the cathode? Net reaction is, now I am going to consider this one as well as this one, right? So this is I am showing for the how the hydrogen gas which is going to be existence. So by comparing this one and this one, I should write the net reaction. Means LHS and RHS, what is the common here? We are going to discriminate. So like this, H plus from the left hand side, H plus from right hand side, I am going to delete here. So what is the remaining? Water plus electron, remaining right side product of H2 gas and OH minus will be there. So this is the net reaction for the cathode one. What about the anode? Once again, anode also competition will be there like this. So now I am going to take here Cl minus, so of chlorine plus electron. So its reduction potential should be positive value, that is 1.36 volt here, as well as because OH minus will be there, right? So how this OH minus come? Which comes from the like this. That's why I am going to take like this water molecules. Oxygen gas is liberated and 4 hydrogen plus and 4 electron plus. So this reduction potential for this one is 1.23 volt, 1.23 volt and 1.36 volt will be there. For anode type reaction, you should only consider the lower reduction potential. By comparing this Cl minus and this one, so which one is the lowest one? that is E naught for this one 1.23 volt will be there, 1.36 volt will be there. So we are going to consider for the lower reduction potential for the anode, we are going to consider the higher reduction potential for the cathode. But here lower reduction will be this one will be there. But what happens? So this oxygen, it requires the over potential. So that's why we are going to not preferring this one in this reaction, because it consumes the over potential. That's why here this chlorine, which is going to acquire less potential compared to this oxygen, right? So this oxygen requires over potential, this is require less potential. That's why for this reaction, for anode reaction, I am going to consider this one as Cl minus only. So that's why by looking all these cathode reactions and anode reactions, I am going to consider the summary here. Summary means NaCl, that is called sodium chloride, our electrolyte, that is for the Na plus and Cl minus here. The cathode reaction, what is the summary of the cathode reaction? That is water molecules plus electron plus half H2 plus hydroxide ions. Whatever the anode reaction, anode I am going to consider this one because of the less potential, Cl minus or Cl2 gas plus electron. So overall this one I am going to write as NaCl. When it is going to be dissolved in the water, we are going to obtain the like this. So this is called the products of the electrolysis. So like this we are going to obtain so many products, right? So that's why we are discussing about the products of the electrolysis. Let's discuss about the batteries. So this is a very important and very interesting topic also. So because you know this one batteries, without batteries there is no life existence, right? So let's discuss about the batteries here. So as a definition does that as a galvanic cell. Yes, galvanic cell. You know the galvanic cell, and example for this one is called Daniel cell, right? So usually a galvanic cell or two or more galvanic cells are there arranged in a series. We are going to call as the batteries or cells, right? So you know this one, batteries, right? So these are the very wonderful inventions of the 21st centuries, right? Because you are going to use calculators also, batteries are required, calculators, mobiles, right? In telephone wires, hearing aids, flashlight, electricals, so many matters of in our daily life. These batteries play a very important role here. So one of the very important role is that is a battery can be used in our cell phone, right? So that is very necessary for this one in our daily life. So here the classification we are going to see here in the batteries or cells. So first one is called primary cells, second one is called secondary cells. So let us look at about these primary cells. In these cells, the reactions occurs only once, and after use over a period of long time, the batteries becomes dead and they cannot be reused further. So that is called, example this one, dry cell and mercury cell. Primary cells means only one can you are going to use, like remote shells, some battery shells, right? Once if you put the shells in the remote, what happens after so many times, after a long time, so what they becomes dead, right? You are going to throw it them because they can't be reused once again. So that they are the example for the dry cells. So like this should be there. What about the secondary cells? Just it is the opposite one. The cells can be recharged several times by passing the electric current in opposite direction and can be reused for a long time. The best example for this one secondary cells is your mobile battery cells, right? So many times you are going to use it, right? Example, lead storage and nickel cadmium cells. Let's discuss about the primary cell. So in that one we are going to discuss about the mercury cell. Mercury cell is nothing but the mercury oxide and zinc cell we are going to use here. So let's take here the cell means there must be containing the anode as well as the cathode because of the reactions should take place here, right? So anode we are going to take it as a zinc amalgam. Amalgam means it is a mixture of the two metals. There is a amalgam means mercury must be containing here and zinc is also placed here. It is called amalgam. Cathode means mercury oxide because as the name indicates mercury oxide HgO and some graphite placed will be there, right? Graphite, that is carbon. And electrolyte we are going to use here the 40% KOH, that is for solutions, right? 40% KOH solution and zinc oxide we are going to take an electrolyte here. So here what happens? So let's take the reactions here, anode reactions. So here zinc, that is called amalgam, that is act as an anode, that is this powder will be there. So and 2 OH minus will be there, that is called an electrolytic solution, that is called KOH, right? In that KOH, OH minus we are going to take here. So what happens? Anode means oxidation. Oxidation means loss of electrons which takes place here. right here. So here in this state, zinc will be in the 0, right? There is no oxidation state here. But what happens in this case? Right this side, now it becomes the +2. +2, 0 to +2 means there will be loss of the 2 electrons. That's why this is the anode reaction. Zinc plus the 2 hydroxide ions, zinc oxide which is going to form here, plus water molecules and 2 electrons. Which is 2 electrons? So that is from the zinc metal, right? 2 electrons will be raised here. What about the cathodes? The cathode means they are going to utilization for the 2 electrons in this reaction, that is mercury oxide plus water molecules. So in this mercury oxide, what is the oxidation state here? Mercury, that becomes +2, whereas in RHS that becomes 0, means +2 to 0. That is called gaining. They are going to gain the 2 electrons here. So now it becomes 0 state plus 2 hydroxide ions. Let's write the overall reaction here. Overall reaction is, so our LHS and RHS should be equal here. So remaining, if they are same, they are going to cancel here. So zinc will be there, 2 OH minus will be there. So here 2 OH minus and 2 OH minus here. So that I am going to cancel here. So cancel here. And here 2 electrons and here 2 electrons I am going to cancel here. And also water molecules. Water molecule. What is the remaining? LHS? Zinc plus mercury oxide. Zinc plus mercury oxide. What is the RHS remaining? ZnO, zinc oxide plus mercury. That is, here also you can see here 0 to +2, loss of electrons, +2 to 0, gain of the 2 electrons. So this is about the net overall cell reaction for this mercury cell. So here cell potential. What is cell potential for this one? That is 1.35 volt will be there for this one mercury cell. So where we are going to use this one mercury cell? That is hearing aids and watches. We are going to use the small shells, right? After the usage of the watches, so you are going to remove the shells, right? But shells, they are not going to proper working after some times because they are dead cells. Means we are not going to reuse it further, right? Just we are going to throwing them. So you are going to see in the small shells, as the picture predicts that the small shells you are going to use in your the watches. Let's discuss about the secondary cell, that is called nickel cadmium cell. So usually they comes as a longer life. So these cells are very longer life and also secondary cells. So here the anode they are going to take the cadmium. So here they are going to take the cadmium CD, that is called CD, and cathode they are going to take as a nickel mainly. So and also this cadmium contains 78% of the cadmium hydroxide, 80% of the iron, and 1% of the graphite, and remaining 1% that contain the nickel. So here this cathode contains the 80% nickel hydroxide, 2% cobalt hydroxide, and the remaining 18% they are contained in the graphite here. So the cell and the electrolyte also they are going to use, that is called KOH, and the cell reaction they are going to write as CD plus 2 nickel hydroxide 2 times. That gives us 2 times of the nickel hydroxide plus cadmium oxide. So this is about the overall cell reaction. So because why it is anode? Because loss of the electrons here 0 to +2 will be there, oxidation state. This is a cell reaction, and this during the charging one, the above cell is just reversed here, just because this is a reversible, right? So this is kind of reversible reaction. Why? Because we are going to use so many times, like examples, mobile batteries to pass the electric current or charging the mobile. So after some several times, that charge goes on decreases. When it comes to a 0 or 10% or nil, what we are going to do? Again, we are going to take, that is called opposite. Thus, you are going to reverse the reaction. So like this, and cell potential should be 1.4 to 1.28 volt will be there. So this is an image of this one also, this nickel cadmium cell. And here where we are going to use this one, that is called pocket calculator, and also we are going to use the hearing aids, and you know this electrical shavers, right? So nowadays trimmers will be coming, right? So that is called nickel cadmium cells. There is, and that is called very small cell will be there, because they produce only 1.4 to 1.28 volt, right? So before going to shaving one, so you are going to charging for several times, half an hour, right? Because of the cells, they are containing very small capacity of the storage, and again you are going to use reusing, right? So that is called secondary cell you are going to use in the shavers.